4.6, we're talking about polynomial and rational inequalities, so it's a little different, but a lot of this stuff is going to be based on the basic same ideas. The first couple of things I'm going to do are real simple to just sort of prepare you for what I'm going to teach you in a little bit with sign charts. You're going to be doing tons of sign charts. All right, this problem right here is a less than problem. You're interested in where this function, which is represented by the graph, is less than 0. What that means is it really means where is f of x below the x-axis. That's what that means. That's all. And you name that in interval notation. So if you look at this little piece right here and this little piece right here are where you're below the x-axis. Okay, so if you were doing that in interval notation, this part right here would be negative infinity until you got to that x-intercept, which, help me out, I think that's negative 3. Yeah. Okay? And then it would be this piece right here, which looks like it's between, help me out, 4 and 8? Yeah. Okay, good. All right, so we would say in interval notation, negative infinity to negative 3, union 4 to 8. Okay, that's what it means. If it's a less than problem, you're looking at where it's below the x-axis. That's it. Okay. Now, there's one mistake I made. I just figured out here. Notice that there is a greater than or equal to. So that means you need to do this. I wasn't paying attention. This is easy stuff to kind of be to overlook sometimes, but you got to be careful when you're doing homework and stuff. So you have to have a bracket there. And you have to have brackets there. That's because it's less than or equal to. So you got to be kind of really careful in this section about your brackets and parentheses. Okay, they're very important. Okay. Okay. Now the next problem is the same thing. Okay, what you're going to do on this just means where's it below. This problem right here, what it really means, number one, you might write a note that it really means below or on the x-axis. That's why I did brackets, because there's places where it's on the x-axis. But this is below only. So what do? We named this in an interval. So we got that slice right there, and we have this slice right there. We named that in interval notation. We'll go back and do the set builder here in just a minute, and I'll show you that because I want you to know that too. So in interval notation, this piece right here looks to me like between negative 4 and 2, not including, would be where it's below the x-axis, right? And then this piece right here looks like from 6 and then to forever, it's going to be below the x-axis. So in interval notation, you would say negative 4 to 2, union 6 to infinity like that. Okay? All right. What if it was greater than? What would you be looking for? Where it's above, exactly. Okay? Now let's go back and let's do these things in set builder notation. In set builder notation, you have to write this like this. You have to say set of x such that x is smaller than negative 3 is what it was on that. So we would say x is less than or equal to negative 3. Then we put a comma. And then if we write between 4 and 8, you have to say 4 is less than or equal to x is less than or equal to 8. That's how you write that x is between two numbers, including two numbers. That's just the language. That's called set builder notation, and we've done that before. Okay, the next problem, you're going to say again, set of x. You're naming these with x values, and it's between negative 4 and 2, not including. So you would say negative 4 is less than x is less than 2, not including, so I didn't put bars there. And then 6 and forever would be x greater than 6. Okay, that's just two different ways of naming the same thing. Okay, does that make any sense? Okay, a lot of language stuff. Those of you that go on to do calculus, you want to get this stuff down good because you'll struggle if you don't, if you get there. Because we do this all the time. It's just a thing that we do constantly with naming intervals. Okay, now let's just do this next one together here. All right, if it's greater than, what do you suppose that's going to mean? Okay, where it's above the x-axis, and it's equal to, so it would be or where it's on the x-axis. Okay, that's the meaning of that. So really this one is, there's two places. It looks like in this little slice right here and this little piece right there look like the two places. Okay, so you just name the intervals. So it looks like between -4 and 2 and including, so you would say -4 to 2 including. Okay, have I got those points right? Because I don't see very good sometimes. Okay, and then it would be, that looks like 5. You think that's 5? Okay, including, so it would be 5 to infinity like that. Okay, so that's where it's above. And in set builder notation, you would say set of x such that -4 is less than or equal to x is less than or equal to 2. And then you would say x is, no, not, the thing is when you name intervals between, you use less thans. If you're naming it's between two numbers, you use less thans. You don't ever use greater thans. Okay? I see why you would ask that question because it is greater than, but it's between -4 and 2, and -4 is less than 2. That's why we do those two less thans. If you didn't, it wouldn't make any sense. Okay? Okay, what do you guys think? Have you got that down okay? Okay, just 17 minutes till spring break. So hang in there. All right.
Or we could just like go early.
We could just go early, but I'd be denying you your education. And I just don't like, I'm very ethical.
Be nice, you're Irish.
I'm very ethical.
Be nice. Let's go celebrate.
Have you guys ever been to Euclids restaurant?
No.
It's on Larimer Square.
Yeah.
You should go there sometimes. And the reason I say that, and I'm not being a bad influence, is because they have a beer list that is named by math levels. So if you get real light beer, it's arithmetic. You order arithmetic. If you like real dark stout beer, you order quantum mechanics. So it goes on a scale from arithmetic through trig and algebra, calculus, all the way to quantum mechanics. So if you go there, it's on Larimer Square. Okay?
Euclid's bar.
Euclids, which is, of course, the name of a mathematician. Okay, gosh, I'm recording this, and I'm being such a bad influence on you guys. Okay. All right. No, it's a good place. You're all adults. Okay, I'm not suggesting anything.
Are we?
Okay. All right, let's go ahead and finish these up. Now, what we're going to do with the next thing
You're right.
is this. We're going to do this with a sign chart. Now, we're going to look at this graphically. So the first thing that you want to do on this is find your zeros. Okay, so you basically have x equals -7 would be a 0. X equals 1 would be a 0. And x equals 4 would. Okay, we're going to do that, and we're going to construct a basic graph on this. Now, you could do this problem graphically, or we could do this with a table of values. This one I'm going to do graphically. I'm going to do a few of them with a sign chart here in a minute. So a lot of times you can handle what we did just graphically. So let's just draw a coordinate system and let's sketch the graph. This is kind of like what you did on your quiz today. So what we're going to do is let's label these things. So we have 1, 2, 3, 4, 5, 6, -7, you have a x-intercept. Okay, x equals 1, you have an x-intercept. And x equals 4, you also have an x-intercept like that. Okay? So the other thing is look at these multiplicities. Okay, the multiplicities are all 1s, right? Okay, what does that tell you about the behavior at these zeros? Do they cross or touch?
Always cross.
They cross. So they cross. We know that for a fact. Okay? Now the other thing is, when you find the degree of a polynomial, I said just add the multiplicities up. So you get 3. Okay? What does that mean? It means the graph is going to do this kind of thing like that. Okay? Or it could possibly do this kind of thing like that. Okay? It's all based on the leading coefficient. So you really just look at these things I'm highlighting and you determine in your head primarily whether that's positive or negative. So for that leading coefficient, you're really just doing like 1x to the first times 1 to the first times 1 to the first. You're just looking at the number in front of x because that's all that matters. So you get a positive which means your graph is going to do this. Okay, do you guys see what I'm saying?
Yeah.
That's exactly like you did on your quiz today. So if you get that down, it'll help you significantly with this problem. So we're going to draw a graph. Okay, basically we know the endpoint behavior is like this. It's an odd polynomial with a positive leading coefficient. So now just sketch the graph. It doesn't have to be accurate. You just need to make it kind of loop through the points like that. That's it. Okay? Now, this is a less than problem. So what are you looking for? Yeah, where it's below the x-axis. So that would be one place. And this right here would be one place. So you're ready to name it. And you got the answer. So see, you don't need to touch your calculator, because you can reason it out in your head, okay? So the idea would be -7, below -7 would be one of the intervals. So we would say -infinity to -7, okay, with a parenthesis because we don't have a equal to bar there. Then we would say from 1 to 4, so we'd say union 1 to 4 like that, okay? And then in set builder notation, you would say set of x. X has got to be less than -7. So when you're less than -7, okay? And then it would be between 1 and 4. Remember, you write this like this. 1 is less than x is less than 4.
Wait, 1 or -1?
What's that? Oh, +1. Why did I put a -1 there? Okay. Okay, like that. Because I'm Irish, that's why I did that. Okay, any questions about the graph and how that goes? Okay, let's do one more like that together. Then I do want to... Okay, I could do this all day.
Well, you're a math teacher.
I could give you all detention. Okay, so let's do this. I do want to do this, and I want to do a couple of things with sign charts. And 10 minutes till spring break, and counting. Okay. All right. So the zero.
You just canceled the algebra lab.
I'm not going to even go there yet. Okay. So we have 8. We have a multiplicity of 2. Then we have -9, and we have a multiplicity of 1. Now we're going to do this graphically again and kind of get the hang of it. Okay, I like to kind of show these problems in 2 different ways. All right, so let's see. Let's go ahead and put this on here. So we're going to go to 8. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have an x-intercept there. Now the multiplicity is 2. So will it touch or cross? Touch because it's even. Okay. Go to -9. 1, 2, 3, 4, 5, 6, 7, 8, -9. Okay, you have a 0 there. The multiplicity is 1. So will it touch or cross? Cross. Okay, how do you find the degree of this polynomial? Add the multiplicities. It's 3. Okay, that means that your graph is going to do this or it's going to do this. Okay. Leading coefficient is what you do. You look at x, that's all you look at, and you do this like this. That's a 1 to the second and a 1 to the first. So you're going to do 1 to the second times 1 to the first, which is positive, which means it's that one. Okay? So when you put your graph together now, your endpoint behavior is going to go like this, and it's going to go like this. Okay? And that's what you're going to do. So then just kind of loop through this. You're going to cross through this x-axis like that. You've got to change directions. It doesn't matter where you change. Now, if you touch, you've got to change directions like that. Okay, so that's roughly how that graph goes. Okay, now this is a greater than problem. Since it's a greater than problem, what are you looking for? Right there. Okay. And you got to be a little careful on this one. These problems can be a little picky, so you got to be really careful how you write your answer to this problem. Okay, now you're going to name this interval. In interval notation, you're going to name it like this. Okay, so we're going to go from -9 to 8. And I'm going to use a parenthesis. Why am I using parentheses? Because of that. It's greater than. It's not greater than or equal to. Then you have to go 8 to infinity. Now you may be thinking, why didn't you just say negative 9 to infinity? That's wrong if you do, because of that not being an equal to. You have to break it up into two intervals. You have to. Okay, so this problem right here means where are you above the x-axis. It doesn't mean where you're on the x-axis. It means where you're above. So that's why that is. And then in your set builder notation, you would say set of x. You would say negative 9 is less than x, less than 8. And then you would say x is greater than 8, like that, and that would be it. Okay? All right, have you got the graph down okay? Okay, now I want to do just one additional thing, and that's with doing this with a sign chart. Okay, graph is one technique. Sign chart is super important that you learn how to do that if you're going to higher math. Okay, so we're going to do this one a little bit more with a sign chart then. Okay. All right, first thing that you always want to do on these problems here is you want one side to be equal to 0. Okay, so do that. Okay, now that's going to be a less than, so we're going to make that less than 0 like that. Okay, all right, now you got to factor. I factored the last two problems, so you got to factor these. Okay, this time just for variety, I'm going to do a sign chart. Okay, if you factor this, you can take out a common factor of x squared. If you do that, you'll be left with x squared minus 81 is less than 0. So if you have a common factor, take it out. Okay. Now, can you factor x squared minus 81?
Yes.
Yes, it's a difference of two squares. Go as far as you can. So we're going to go, like, draw two parentheses, x and x to give x squared, 9 and 9 to give 81, with a plus and minus like that. Okay? Now we're going to solve this problem not graphically. We're going to solve it with a sign chart just for something different, because there's two ways to do this. So what I'm going to have you do is draw a line, like we did sign charts earlier in the last section. And now go ahead, what you want to do is you want to look at your zeros. So that's going to be x equals 0. This is going to be x equals negative 9. This is going to be x equals positive 9, like that. Okay? So you need to just break up your sign chart into 0, negative 9, and 9. Don't worry about asymptotes. We're talking about polynomial function. There is no asymptotes on this. It's a polynomial function. Okay? So we're just going to put like dashed lines like that. And like that. Okay? And what we're going to do is we're going to do a sign chart. You may find on a lot of these problems it may be faster to do graphing. If you get it down, it probably is. So we're going to plug our test points in here. And again, all we got to do is most of this in our head. All right, so let's take a test point lower than negative 9. Let's say like negative 10. Okay? You're going to do negative 10 to the second times negative 10 plus 9 times negative 10 minus 9. Again, all I'm doing is plugging that test point in for x. Okay? Now do this way. Don't waste your time. If you take negative 10 to the second, you get a positive, right? I don't care if it's 100. I just care it's positive. If you do negative 10 plus 9, that's negative. Who cares that it's negative 1? And then if you do negative 10 minus 9, that's negative. So what's a positive times a negative times a negative? It's a positive, right? Okay. So that means you're going to be above the x-axis, okay, like that. Okay. Now let's push on to the next interval, which is, let's use negative 1 as our test point. So we're going to go negative 1 to the second times, down here again, negative 1 plus 9 times negative 1 minus 9. Okay, that's positive. This is positive. That's negative. You guys see what I'm doing? Okay, don't waste your time crunching it out. I see students do it all the time. Doesn't matter. What is your answer? Negative. What does that tell you? Okay, you are below the x-axis. Okay, that's the idea. Okay, now let's go in here. Let's use 1. Plug it in. You're going to go 1 to the second times 1 plus 9 times 1 minus 9. Okay, 1 to the second is positive, 1 plus 9 is positive, 1 minus 9 is negative. So what's the result? So we're below. See, I told you the signs don't always alternate. They often do, but not always. And then let's use 10 out here. So we're going to do 10 to the second times 10 plus 9 times 10 minus 9. We have a positive times a positive times a positive. So that means we're above the x-axis. Now, we're not going to draw a graph. We don't need to draw a graph. If you look at the problem, now you have to set one side equal to 0. What are we looking for? If it's less than, what am I looking for?
Below.
Yeah, where it's below, okay? Those are the two places right there, okay? So you name that in an interval notation. So when you do this, you're basically going to say, and I'm going to just draw a graph on this because sometimes it is helpful for students to see the graph on the number line. It's basically parentheses, negative 9 to 0, shaded in between, and then it's 0 to 9, shaded in between, but you have to exclude the 0, okay, because it's less than. So you would have to say for interval notation, you'd have to say negative 9 to 0, union 0 to 9. You can't put that in one interval. You could if it was less than or equal to, but you can't in this case. And then in interval notation, you'd have to say set of x such that negative 9 is less than x is less than 0, and 0 is less than x is less than 9. That's the answer to the problem. Now, this problem like this, all of these problems can be checked on your graphing calculator. If you're doing your homework, you want to do it analytically so that you understand this, but you could put this in your graphing calculator. You could just put in y1 equals, you could even put it in this form, and you'll see a graph, and you could kind of see if your answer makes any sense to you. So you just put that in, and then you're done. Gosh, I could just do this all day. You want to do another one? We got 30 seconds.
You do one in 30 seconds?
No, I can't do one in 30 seconds. Happy spring break, guys. And one question, are you going to study during spring break?
Yes.
Oh, yeah.